These are iron meteorite slices, and they have been soaking in this bath for over a week. And the bath does one job. It pulls chloride salts out of the metal. Those chlorides are what drive a meteorite to rust from the inside out. So getting them out stops the rust at its source. The bath itself is just two chemicals, sodium hydroxide and sodium sulfite. To find out whether the bath is still working, I test it. On the right is my control, fresh bath that has never touched a meteorite, and on the left is the used bath. And this is 40% nitric acid, which I need first before I can run the actual test. So here's where the acid comes first. This bath is strongly alkaline, and it's loaded with sulfite. If I drop silver nitrate straight into it, the alkalinity throws down a brown silver oxide, and the sulfite gets in the way too. And what happens is I get a muddy false result. So I have to bring the pH down before the test will read clean. You can see the fizzing as I add the acid. That bubbling is the sulfite reacting and leaving the liquid as sulfur dioxide gas. This is why I run this with good ventilation, because gas is an irritant. The fizzing is also my gauge. As long as it keeps fizzing, the sample is still alkaline. When I add drop and I get no more fizz at all, I know I'm acidic enough, down to the range where the test works properly. It takes a fair amount of acid to get there, and that's on purpose. This bath is concentrated, so it soaks up a lot of acid before it gives in. Even at 40%, expect a good run of drops before the bubbling quits. The one rule here is that both tubes get treated exactly the same, drop for drop. The control gets the same acid as the used water, so that the only real difference left between them is whatever came out of the meteorites. Once the fizzing stops, I add 2 more drops just to be safe, and this tube is ready. Alright, so now that I've reduced the pH on these 2 tubes, I start with the actual test itself. So I'm going to take a bottle of silver nitrate. You can get this pretty much anywhere. And I'm going to put 2 drops in each of these tubes. One into the control and one into the used water. And you'll see that when I drop into the control, it stays almost clear. And the used bath is going to turn milky white, because this is my first bath with these meteorites. Here's what's happening. Silver nitrate reacts with chloride to form silver chloride, and the silver chloride is a solid that will not dissolve, so it clouds the water. The more chloride there is, the heavier that cloud. That milkiness is chloride that was pulled straight out of these meteorites. And this is why the control matters. Even a fresh bath can carry a trace amount of chloride from the chemicals themselves, and the acid dilutes things a little. Running the control the same way cancels all of that out. So I know the extra cloudiness, on the right is real. It also tells me when I'm finished. As these slices stabilize over the coming weeks, each new test comes out fainter, hopefully. When a week or so old bath reads no cloudier than the fresh control, the chloride is out and the piece is stable. For now, this milky result tells me that they still have chloride to give, so they go back in with a fresh solution. And that's the entire test.